Good morning, everybody. This is Mr. Stroud. Hopefully you guys are having a nice little break. I decided to prepare this video for you. I do think it's extremely important. We're into solving equations. I really want this done without a calculator. Excuse me, and it will help you review all your arithmetic. All right. Now what I'm going to do is I'm going to go through and do the odds. I'm going to leave the last 6 or 7 for you to do over the weekend. And then next week I'm going to do the evens on our next class meeting. All right, so please go ahead and follow along with me. And hopefully you find this getting easier. All right, so here we go. Let's start out with number 1. All right, this was just a one-step equation. So what we're going to do is we're going to add 5 to both sides. When we do that, remember, this cancels. All right, and we're left with x equals -3 plus 5 is 2. All right, number 3. Now, for question number 3, we have a fraction that we are multiplying. All right, so how do we undo a multiplication with a fraction? We always say we multiply by the reciprocal. What's the reciprocal of 2/3? That would be 3/2. So we're multiplying both sides by 3/2. Okay? Now what happens? The 3's cancel, the 2's cancel, and we end up with x equals. Remember, I always taught you to divide first. -18 divided by 2 is -9. And then we would say -9 times 3, and that equals -27. All right? So anytime you want to undo a multiplying fraction, we say you multiply by the reciprocal. All right? Don't forget, you're always trying to isolate the variable. All right? That's your job. All right, number 5 is a nice problem because it's got a decimal. We're going to review decimals now. We're going to subtract 1.75 from both sides. Subtract 1.75 from both sides. All right, don't forget when you're doing the decimals. All right, line up the decimals. All right, now again, these cancel, and you are left with x equals. All right, now you're borrowing. Remember, 24 becomes a 23. That becomes a 10. 10 minus 5 is 5. 23 minus 17 is 6. All right, so my answer is x equals 0.65. Notice I'm not using a calculator. All right, you need to practice. All right, please practice. All right, number 7 is important because, again, we are isolating the x value. All right, when we isolate the x value, undoing multiplication, we would divide both sides by -9. Divide both sides by -9. Now, it doesn't always work out. All right, in this case, the -9's cancel, but you're left with 7 divided by -9. That does not divide evenly, so we just leave it. -7/9. All right? All right, again, these types of questions were just a review from last week. All right? Now, again, some of you guys are not showing your work correctly. So I will be sending these worksheets back, telling you to redo them if the work is not shown. All right, so please do that. Number 9, we call it a two-step equation. All right, again, we're trying to isolate the x. All right, we're trying to isolate the x. That means I need to remove the -6, and I need to remove the 3/5. All right, so to do that, we're doing PEMDAS backwards, remember, which means I have to get rid of the addition and subtraction first. All right, so I'm going to get rid of the -6 by adding 6 to both sides. And then I get 3/5 x equals 9. All right, Now, I'm going to multiply by the reciprocal. So here, I'm going to multiply by 5 over 3 times 5 over 3. The reason why I'm doing that is because the 5 again cancels, the 3 cancels, all right? So now let's review. X equals, always divide first. 9 divided by 3 is 3. 3 times 5 is 15. So X is equal to 15. All right, now again, that's still kind of a review. All right, you should be in pretty good shape with that. All right, let's try number 11. Now, for number 11, this is the one where it's a little bit different from last week. Remember, you're dividing that quantity by 7. Since we're dividing that quantity by 7, I have to get rid of the division first. All right, this is something you're just going to have to remember and practice. All right, I want to get rid of the dividing by 7. So to get rid of the dividing by 7, I'm going to have to multiply both sides by 7. Now look what happens. The multiply by 7, the divide by 7 cancel. So I'm left with x plus 4 equals negative 21. Then from there, subtract 4, x equals negative 25. I feel happy about that. Now, the next problem is our new topic, all right? We have to put combining terms into effect here. So I want you to make sure you write this down, make yourself a good note. Variables equal numbers. What that means is I'm always trying to move my variables to the left. I'm always trying to move my numbers or put my numbers on the right. All right, now we're saying on the left and right of what? We're on the left and right of the equal sign. So if you look at this, the 7x is on the left side, the negative 8 is on the left side, the 3x is on the right side, and the 8 is on the right side. I want the variables on the left side. So that means this guy right here is not in the right spot. This guy has to come all the way over with the other guy. All right, we want to combine variables. So how do I move that over? Same principle. If there is a plus 3x on the right side, you would do a minus 3x to move it to the other side. Then you would have to try now and move this number. This number is on the left side. I want it on the right side. So I'd have to add 8 to both sides. All right? Now, combining like terms. So when I combine like terms, you should see this right here, 7x minus 3x as 4x. What happens to these? They cancel. 3x and negative 3x cancel. And now you're left with 4x equals 8 plus 8 is 16. Now how do we undo multiplication? We divide. So x equals 4. All right? Now again, that wasn't that bad. Remember, this is the key. Variables on one side of the equation, numbers on the right side of the equation. Let's check out 15. All right, now this is another problem here. All right, a new problem. This is proportions. Okay, so to solve a proportion, we've already done this. All right, we say we cross multiply. Everybody remember that. Whenever you see a proportion, you cross multiply. What does cross multiply mean? It means you multiply the 3x minus 4 times the 2, and then you're going to multiply the 2 times the x minus 3. All right, that's what is meant by cross multiplying. All right, multiplying this way. Now, when we cross multiply, it ends up becoming 2, open parentheses, 3x minus 4 equals 2, open parentheses, x minus 3. Now we have parentheses, all right? So what do we need to do for parentheses? Well, we have to distribute. When we distribute, we end up with 2 times 3x, 6x. 2 times negative 4 is negative 8. Now I'm going to distribute the 2 over here. That becomes 2 times x, which is 2x, and 2 times negative 3, which is negative 6. Now we're back to variables on the left, numbers on the right. So I'm now going to take the 2x and move it to the left. I'm going to take the 8 and I'm going to move it to the right. Notice every time I move a variable or a number, I change the sign. Now you should be able to see the negative 8 and the positive 8 cancel out. The 2x and the negative 2x cancel out. And now you're left with 4x equals 2. Now we want to divide both sides by 4. Now remember, 2 divided by 4 is a fraction. It's not 2. X equals 1/2. All right, x equals 1/2. Question number 17. All right, we have a distributive property here. Again, negative 3 times 2x, negative 6x. Negative 3 times negative 5 is positive 15. Minus 7 equals 14. Now, before we try to simplify anything, we always say we combine terms. All right, and 15 minus 7 is 8. So I have negative 6x plus 8 equals 14. Now again, we're back to numbers on the right side of the equation. So I'm looking at this plus 8 and it's in the wrong spot. So I have to subtract 8. And now I have negative 6x equals 6. Dividing both sides by negative 6, I have x equals negative 1. Please look over that. That's another really nice problem. Right? The important part is you're not just writing down the information, writing down what I'm saying, but you're supposed to be concentrating on what I'm doing. Stop the video, pause the video, restart the video, make sure you understand what I'm doing. All right, that is super important. Number 19. Now it looks a little bit harder because we have fractions, but we are not scared of fraction because we are good at fractions. So let's start. So again, variables equal numbers. This negative 2 is a number. I need to push that to the right side. To push that to the right side, I add 2 to both sides. The 1/2 x is on the right side. Variables go on the left side. So I have to minus 1/2 x. Minus 1/2 x. Now again, the reason why we're doing that is because the negative 2 and the positive 2 cancel. The 1/2 x and the negative 1/2 cancel. And now 7 plus 2 is 9. And now I'm pretty certain we all can do 3/4 minus 1/2. But just as review, I'm working it out. We need a common denominator. 1/2 is the same as 2/4. Of course, I had to multiply both by 2. And so now I have 3/4 minus 2/4, which is 1/4. So now I have 1/4 x is equal to 9. Now I just multiply by the reciprocal, all right? Again, the reciprocal 1/4 is 4. So I'm really just multiplying both sides by 4. Then these cancel. X equals 36. Please, again, look over your fractions. All right, I know some of you are great at mental math and you already knew 3/4 minus 1/2 was 2/4, but make sure, right, that you understand you have to you have to review your fractions, please. Make sure you know them extremely well. Now, number 21. We want to distribute -3. So -3 times 4x is -12x. -3 times +6, -18 equals 8x plus 78. Now we're in a position where you want to do variables equal numbers. So again, I'm looking at this going, the -18 is in the wrong side. So I want to add 18, add 18. The 8x is in the wrong spot. So I move that by subtracting 8x, subtracting 8x. Now we know that 8x and -8x cancel, -18, +18 cancels. And so now I'm left with -20x is equal to 96. Now this is kind of ugly because it doesn't divide evenly. So let's go ahead and divide by -20, divide by -20. X equals a positive divided by a negative is a negative. Now we're going to reduce this fraction. You don't need your calculator. All right, we know that they're both even. So I'm going to divide by 2 to start out with. All right, that becomes 48 over 10. Now I can divide by 2 again. So that's 24 over 5. Now some of you already looked at that and said 96 and 20 are divisible by 4. If we can do that, just divide by 4. Okay, but this final answer, -24 over 5. Now, that's not too bad at all. Please again, review though. All right, don't just write down my answers. Go back, understand the question. All right, understand the question, please. Back to 23. Variables equal numbers. So let's figure out what's in the wrong spot. The -3 is in the wrong spot, and the 7x is in the wrong spot. So we're going to add 3, minus 7x, minus 7x. Now what happens? These two cancel, these two cancel, right? And now we've moved them into the right spot. So I have 2x minus 7x, -5x. Combining the 12 and the 3, 15. Divide both sides by -5. So x equals -3. Another really good review problem. Please go back, double check everything. You should be getting a little better as I go down the page. 25. All right, what do we see on 25? We see on 25 that it is a proportion. What is a proportion? I told you you're supposed to cross multiply. Those two things get multiplied. Those two things get multiplied. That's what's meant by cross multiplying. So 5 parentheses 2x plus 1 equals 3 parentheses 3 minus 2x. Now, we're going to do some distributing, right? 5 times 2x 10x. 5 times 1, positive 5. 3 times 3, 9. 3 times negative 2x, negative 6x. Again, we're back to variables on the left, numbers on the right. I've got to move negative 6x, I have to move positive 5. So to do that, I'm going to do minus 5, positive 6x. Now we're going to look at that carefully. We get 16x is equal to 4. Divide both sides by 16. Now again, the mistake that's made here is for kids to just say it's 4. But look at that carefully, that's a fraction. 4 over 16 reduces to 1/4, not 4. Make sure you look that over, please. All right, take a good look at that. Make sure you didn't put 4 down. Okay, let's go to 27. Okay, now I need everybody to highlight 27, please. This is a special case. All right, we're going to talk about 2 special cases now. All right, when you look at this, I want you to see, when does 3x minus 12 equal 3x minus 12? Well, 3x minus 12 equals 3x minus 12. That is called an identity. When does 3x minus 12 equal 3x minus 12? It always is equal. And what does that exactly does that mean? That means it doesn't matter what the x value is, 3x minus 12 is always going to be the same as 3x minus 12. When something is an identity, we say that the solution is all real numbers. All right, we say it's all real numbers. Now, I'll give you another example. So if I say, when does x minus 7 equal x minus 7? Again, x minus 7 always equals x minus 7. So we say that's an identity, and we can just say it's all real numbers. All right, now I want to look back at number 20. I want to look back at, for example, 23, just to give you an example of what I mean. All right, when does 2x minus 3 equal 7x plus 12? When are those things equal? Those things are equal when x equals negative 3. The only time those things are equal is when x equals negative 3. There's only one solution for that equation. No matter what number I plug in, they're not going to be equal unless you plug in x equals negative 3. Well, now let's drop that back down to 27. Doesn't matter what you plug in for 27, it's always going to be the same. So there isn't just one solution. We say there's an infinite number of solutions, or that it's all real numbers. Now, there's one other thing I want to talk about right here that you might come up with, all right, is I want you to think about if I said, when does x equal x minus 3? Well, that should look strange to you. When can a number equal itself minus 3? That is called a contradiction. That doesn't make any sense. A number cannot equal itself and itself minus 3. So we would say this, in fact, because it's a contradiction, we say that there is no solution. Now the symbol for no solution, again, is the 0 with a line through it. All right, so whenever you come up to a contradiction, you will say that there is no solution. I'll give you another example. I say 3x minus 4 equals 3x plus 2, immediately you should look at that and say that's a contradiction. How do I know it's a contradiction? Because 3x minus 4 is not possible. There's no way that can be 3x plus 2. Now, you might say, well, I'm not going to remember that. So there's a way in math to kind of show yourself whether it's an identity or whether it's no solution. So what I want to do is if I do a minus 3x plus 4 plus 4, this cancels, so I have 0 equals 6. Well, there's your contradiction. 0 equals 6. All right, because it's a contradiction, we would say it's no solution. All right, now let me show you how you know if it's an identity, if you forget. All right, so let's go back to this. So here I'm going to subtract 3x. I'm going to add 12. Now you notice what happens. We don't reach a contradiction. We just get everything cancels out. So if everything cancels out, we say 0 equals 0. That's the sign that it is a what? Identity. All right? That shows that it's an identity. All right? Which means that it is all real numbers. All right? So those are the two now really super important things. Now what I want to do is I'm going to look ahead and I'm going to possibly do a couple hard ones. But what I want you to do now for your homework is every odd number that I skip, that's what I want you to do and submit to me, and then I'm going to look over it and see how you're doing. All right? And then we will meet back again on the next time we meet, and we're going to do the evens. So let's look. You're responsible for 29. You're responsible for 31. You're responsible for 33. You're responsible for 35. You're responsible for 37. You're responsible for 39, 41, 43. 45 is a really great review of fractions. So put a star by that one. I want you to really concentrate on 45. 47 you can do, just doing the distributive property. 49, combining terms, variables on the left, numbers on the right. I think that's a good way to end. Now, what I want you to do now, remember what I said, only finish the odds. Only finish the odds. 51, 49, 47, 45. Or I do all the odds that I did not do, submit it, and then I'm going to kind of look at it and see how you're doing. Show your work. Now, keep in mind, I know we weren't supposed to meet today. I know it's Easter, but, you know, what else are you going to do? All right, you're locked in your house. You might as well do some math. That's what I do all day. I love what I'm doing, and I really miss you guys, and I want you guys to be really ready for next year's algebra class. So do me a favor, please work on these problems, on the odds, and then submit them to me, and then I'll look them over, and I'll send them back, and I'll tell you how I think you're doing. All right? I sure miss you guys, and I hope to see you soon. I'm going to write an email to your parents explaining exactly what I want you to do. You guys have a nice day.